Now, coming to the variable covalency, which I left you in the last class, the variable covalency, I said you that just like variable electrovalency, there is also variable covalency. That is, I said you that if I ask you what is the covalency of chlorine, you may say it is 1 because chlorine has 7 electrons in the outermost shell, so it is 1, correct? But it has also got variable covalency of 1, 3, 5 and 7. Alright, for that particular reason you will be getting the compound like Cl2O, Cl2O3, Cl2O5, Cl2O7. For that reason the compound exists because due to the variable covalency of chlorine. Now the question comes how? How it is possible that a particular element like chlorine, phosphorus, then sulfur, it shows variable, and so many other elements are also there, they show variable covalency. So just I am giving some examples, you look at the board and try to understand here. Now, chlorine atomic number is 17. So it is 1s2, then 2s2, then 2p6, 3s2, then 3p5. So as you can see, it has got 7 electrons in the outermost shell. 7. Alright, so 6, 4, 10, 2, 12, 5, 17. So 7 electrons is there. Now I am always interested in the outermost shell only. Remember, I am always interested in the outermost shell. I am not interested at all with the innermost shell because innermost shell, the what you can say, the orbitals are fully filled. Alright. So 3s2, so 2 electrons, 3p5, 1, 2, 3 and 4 and 5. You can see. So as a result, you can see one unpaired electron is there, due to which its valency is 1. Because number of unpaired electrons will give its valency, definitely. So now see here. Now listen. 3s subshell is there, 3p subshell is there. Even 3d subshell is also there, but that is not required. That is completely vacant. Listen carefully here. In chlorine, you can see the p subshell is only not complete. So there is no question of any 3d subshell here. But 3d subshell is present because third shell, what is the maximum capacity? 18 electrons. So here it is 2, here it is 6. Maximum is 6 now. Of course it is 5 here, but maximum is 6. S subshell maximum is 2, P subshell maximum is 6, D subshell maximum is 10. So you add it, 2 plus 6, 8, 8 plus 10 is 18. So D subshell is there. But here I have not written D subshell because P is not only complete, so why should I write D? Alright. So that does not mean that D is not there, D is there. So D is what? Completely vacant. It is completely vacant, D subshell is. So what will happen is that when I provide energy in the first excited state, what is going to happen? Electron is going to gain energy in the P subshell and it is going to jump into the nearest D subshell. Got it? In the first excited state means when I am going to provide some energy to what you can say the chlorine atom, then the electrons from P subshell, this particular electron, will jump into the vacant D subshell. That means what will happen in the first, that is excited state, what is going to happen? There's 2 electrons here and here it is what you can say, that is your 6 electrons are here, 5 electrons are there, 1, 2, 3, 4 and 1 electron from here will go to the vacant D subshell. D is having 1, 2, 3, 4 and 5. Alright, so 1 electron will go here. So hence you will be having here, that is nothing but 3s2, then 3d4, 3p4 and 3d1. So how many vacant subshells is there? You can see. How many there is unpaired electrons is there? 1, 2, 3. So hence its valency is 3. Valency is 3. Alright, now when I provide some energy to it, then 1 electron from the P subshell will jump into the vacant D subshell. As you can see it here, this particular electron, it jumps into the vacant D subshell. And hence you have got 3 unpaired electrons, due to which its covalency is 3. Clear now? Now, in the second excited state, what is going to happen? Here it is S subshell, 2 electrons. Here it is P subshell, as you can see, 1, 2 and this. So 1 electron from here will jump into the vacant D subshell. 1, 2, 3, 4 and 5. So 1 electron from here, already 1 electron was there, so 1 more electron came. So it is 3s2, then it is 3p3 and it is 3d2. So how many vacant is there? 1, 2, 3, 4, 5. So hence its covalency is 5, we can say. I think you are getting it now. Now, in the third excited state, what is happen? What is going to happen? Here it is 3s, 1 electron. Now, p subshell, all are unpaired. We don't have any paired electrons. Got it? Now, it will come to the s subshell. S subshell, one paired is there. Got it? So, 1 electron from here will jump. So, here already 2 was there. So, 1 electron from the s subshell will jump into the vacant d subshell. So, it is 3s1, 3p3 and 3d3. So, count it how many unpaired? 1, 2, 3, 4, 5, 6, 7. So, its covalency is 7. For that reason, chlorine has got a variable covalency of 1, 3, 5 and 7. In this way, it has got a variable covalency, due to which here the formula will be with oxygen. Let us say it will be Cl2O, because oxygen valence is 2, while chlorine is 1, so it is Cl2O. Here it will be Cl2O3, oxygen 2, where chlorine is 3. Here it will be Cl2O5 and here it will be Cl2O7 in this way. Alright, now don't say sir it will go to 2p subshell. No. Always I said you outermost subshell is involved in the bond formation, always. So this is your outermost shell and the subshell. This outermost shell and the outermost shell is involved. So it is outermost shell 3s2 and 3p5. So hence this is involved, we can say that. Clear now? So in this way, similarly, you can also see for sulfur, I will show you. Sulfur also has variable covalency of 2, 4 and 6. Let me show you for sulfur. So same thing it is. That is, you can see it here for sulfur. Sulfur atomic number 16. So 1s2, 2s2, 2p6, 3s2 and 3p4. You can see 6 electrons are there. In case of sulfur, 6 electrons are there. Fine. Now, next is in the ground state. In the ground state, what it will be? So, that is 3s, 2 electrons and 3p4. 1, 2, 3, 4. So, there is 2 unpaired electrons is there, 2 unpaired. So, its valency is 2. Very simple. The valency is 2. See, in the ground state. Now, in the first excited state, what will happen? S2, P, it is 1, 2, 3. 1 electron from here, from the p subshell, goes to the vacant D subshell here. So it will be 3s2, 3p3 and 3d, but you can say 1. So how many unpaired electrons is there? 1, 2, 3, 4. So its valency is equal to 4. Alright, now in the second excited state, what you find is that 1 electron from the s subshell. Now p subshell is all are unpaired, so 1 electron from the s subshell will jump to the nearest, what you can say, D. It will jump to P and from P it will go to D. Alright, so in this way we got it 3s1, 3p3 and 3d2. So how many unpaired? 1, 2, 3, 4, 5, 6. So its covalency is 6. So in this way, sulfur shows a variable covalency of 2, 4 and 6. We can say that. Clear? So we understood about variable covalency and why does it show also we came to know. So in this way, many elements are there. It shows a variable covalency. Fine. Now next is accordingly sulfur. You will be finding out different compounds are there. Like SO2 is there. Then H2SO4 is there. Or it H2S2O5, then H2S2O6, H2S2O8, H2SO5, many compounds are there. You will be reading in P block elements in group 16 in class 12. We will be studying about sulfur. Different types of compounds are there, and it is forming different types of compounds due to the variable covalency of sulfur only. It forms different types of compounds of sulfur. It is being formed. Now, you understood about covalency, electrovalency and covalency. You have understood variable electrovalency, variable covalency. Now, next is that we studied that what is the criteria for the bond formation? I said you One is that it should attain the nearest inert gas configuration. Got it? If an element, the outermost shell is partially filled, then to attain the nearest inert gas configuration, it either shares electrons or it either donates or accepts electron, we can say that. Means either it can form electrovalent bond or covalent bond, we have studied. Fine about it. Now, next is there are also certain compounds are there, alright, which does not obey the octet rule. Now, which I said you that to attain the nearest inert gas configuration, that means to attain the nearest octet structure. Alright, it either shares electrons, it either what you can say transfers electrons, or it either what you can say accepts electron. That is, loss or gain of electron is taking place, or sharing of electrons taking place. By doing so, what it happens? The elements or the atom attains the octet structure. Octet structure. That is one of the criteria I've said you, I've discussed with you. Fine. Now, there are exceptions. I said you in chemistry there is a full of exceptions are there. If you read, alright. So there are many compounds are there which have less than 8 electrons in the outermost shell, but still then they are stable. There are also many compounds are there which have got more than 8 electrons in the outermost shell, still then they are quite stable. Alright, that means in either of the cases they do not obey the octet rule. Alright, in either of the cases, fine. There are also many compounds are there which have also got odd electron pair. Odd electron means? Odd electron pair, what does it mean? It means that is like nitric oxide. If you see in one bond 3 electrons are being there, isn't it? Quite strange all these things are. Yes, it is existing. You know that inert gases does not form any compound with any elements because inert gases is fully filled. Alright, it's fully filled. Its outermost shell is fully filled. It has got an octet structure. Alright, that is leaving behind helium. Helium has got duplet. Otherwise, neon, argon, krypton, xenon, radon, it has got an octet structure. But still then, it undergoes bond formation with fluorine, with oxygen. It undergoes bond formation. Alright. Now, let me give you a few examples. Then I will come to the reason why it is so. Even if the compounds which does not obey the octet structure, that means it has got less than 8 electrons in the outermost shell, it has got more than 8 electrons in the outermost shell, it has also got 8 electrons in the outermost shell and hence also it forms a stable compound. It has also got odd electron pairs and hence it forms a stable compound. How it is possible? Now, how it is possible that I am going to tell you in the next. Alright. But what are those compounds? Let me tell you so that you will come to know, yes, these compounds are existing. Alright. And of course, it has got more than 8, less than 8, odd, and this, what you can say. For example, there are certain compounds which are said it has got less than 8 electrons in the outermost shell, we can say that. Alright, it has got deficiency of electrons in the outermost shell. Clear? What are those compounds? Like BeCl2, alright, then BCl3, we can say, or BF3, we can say. Clear? In this way. Or we can say AlCl3, the compounds like. Alright, now we will count it and see that how it has got less than 8 electrons in the outermost shell. Got it? But it is stable. All these compounds are stable, you know. Beryllium has got lithium, hydrogen, helium, lithium, beryllium. Beryllium has got 2 electrons in the outermost shell. Atomic number 4, 2 electrons in the outermost shell. So it requires how many more electrons to become stable? 6. But it gets 2 electrons from 2 chlorine. So it has got how many now? 4. It has got 4 electrons in the outermost shell. It is stable. Boron. After beryllium, boron. Boron has got 3 electrons in the outermost shell. It gains 3 electrons. It shares 3 electrons from 3 chlorine. It in total has got 6. Same thing BF3. BCl3, BF3 both the same, isn't it? So same halogens it is. So it has got 6. AlCl3. Al has got 3 electrons in the outermost shell. Atomic number is 13. 1s2, 2s2, 2p6, 3s2, 3p1. 3s2, 3p1. Alright, so it has got 3 electrons in the outermost shell. 3 more electrons it gains from chlorine. So it has got 6. See, all these are having less than 8 electrons. It has got deficiency of electrons in the outermost shell to attain the octet structure. But still then, these compounds are stable in nature. Why? Alright, I am going to tell you the reason why it is. Alright, don't worry. Now, there are certain compounds which has got more than 8 electrons in the outermost shell. But still then they are stable. SF6. PCl5, IF7, alright, in this way. Now sulfur has got 6 electrons in the outermost shell, atomic number 16. 6 more electrons it gains from chlorine, total it is how much? 12. Phosphorus got 5 electrons in the outermost shell, atomic number 15. 5 more electrons, it is 10. Now iodine has got 7 electrons in the outermost shell. Got it? Iodine, it has got 7 electrons in the outermost shell because it belongs to group 17, so it is halogens, so it has got 7 electrons in the outermost shell. So its atomic number is that is 35 plus 32, 32 add it, how much you are going to get it? That is nothing but 60, 30, 30, 60, 67, we can say that. Clear? So that is the atomic number, okay, because it is nothing but fluorine, chlorine, bromine, iodine. The first shell, you leave it, the first period, then second fluorine, then chlorine, then bromine, then iodine. 2, 8, 8, 18, 18, yeah. So 35 plus 18, got it, I am wrong, that is not 32 because something was going in my mind. So it is 35 plus 18, 35 is for bromine plus 18 you add it, clear. So 35 plus 18 is nothing but it's going to come how much? 45, 550, 53, correct. So iodine has got atomic number 53, whatever it is, it has got 7 electrons in the outermost shell, iodine. So 7 it gains from another fluorine, so hence it is, how much it is? 14 electrons is there. Got it? See here, it has got more than 8 electrons in the outermost shell, but still then they are stable compound. Now, there is compound like XeF2, there is compound XeF6, there is compound XeOF2. Got it? These are all stable. Xenon, it is stable. Even krypton also forms compound with fluorine, KrF2, we can say that. So in this way, these are all stable, we can say that. This compound, xenon is quite stable element, inert gas, but why it combines with fluorine? Why? What is the reason behind it? Similarly, there is odd electron pairs like NO is there. Alright, then we are having, that is the compound that is your ClO2. Then we are having the compound that is something but O2, NO2. So many compounds are there which has got odd electron pairs, you can say that. So how these compounds are existing? Even if they do not obey the octet structure, even if they have got 8 electrons in the outermost shell, less than 8 electrons in the outermost shell, more than 8 electrons in the outermost shell, it has got 8 electrons in the outermost shell, still then they are stable. So there are so many exceptions, you can see that. How these compounds are existing, theories are there for it. I am going to tell you in the next video. Thank you.